Welcome to Philoctetes Center. Francis Levy and I are co-directors of the center. The paintings that you see on the wall, called Portraiture, Old Masters and New, has just gone up. And Kohn, as usual, has curated the work. And Adam has been helpful to them. A couple other announcements. On Tuesday, we have Greek poetry through the millennia, and the program will begin at 7 p.m. with Rachel Hadas as the moderator and Peter Constantine and Karen Van Dyke as participants. Then on March 12, we'll have the last of this series, which will be Theory of Everything. Today's roundtable is on limitations, which is a subject that can be approached from many directions and perspectives. For instance, we can ask, will science ever be able to explain notions such as beauty, responsibility, or meaning? Or we can wonder whether the universe can ever be fully explained mathematically. And again, can the problem of consciousness and maybe even unconsciousness be resolved through science? Our panel will deal with these issues and others, I'm sure, during this roundtable. I think it doesn't escape anyone that when we speak about today's subject, as well as the subject we had a couple of weeks ago on the nature of reality, that the idea of the existence of God is somehow in the background. And we will see if that comes up today or not. With that, I would like to introduce Professor Kohn, who will moderate the session, and he will introduce the other panelists. We have agreed with Professor Kohn that we would make these introductions very brief. So I'll start with him. He is a professor of Emeritus of Mathematics at Princeton University. He is a winner of the Mathematical Society Still Prize and the Bergman Prize, and is a member of the United States National Academy of Sciences and of the American Academy of Arts and Sciences. Joe.
Well, thank you very much. I know it was too long because we had a discussion about introductions, and I said, well, I would just as soon introduce people just as Professor such and such. And you said yes, so that's what I'm going to do. You do have a sheet where various other attributes are explained. So I am, of course, very happy to be at this distinguished roundtable and with such extremely distinguished panelists. And I would like to just make a few remarks about the nature of limitation, and then we'll open up for discussion. So I think that the basic nature of limitation of knowledge is best illustrated in the allegory of Plato's cave, where you have people that sit and they're constrained to do nothing except watch. There's a fire behind them, and they watch shadows flickering on the walls of the cave. And the knowledge, they have to somehow find out what reality is behind it. So they have to use a kind of a creative part of their minds to figure out what's going on. And naturally, Plato wants them to have the help of philosophers to do this, but whatever. That is the problem presented with understanding reality, that our senses are very limited, and if you look at people saying, what's an electron? Well, you see some sort of shadow, some kind of a little trace in some kind of photographic plate or subatomic particle and so on. So that is the nature of limitation. This is a limitation to our basic knowledge. But there's another limitation which I want to emphasize, and that's the sort of the opposite of Plato's cave. Suppose that you are put in a room which, instead of having just flickering shadows, you can see everything, absolutely everything you want. Well, that's not so wonderful. They don't have all the knowledge, because now your brain has to figure it out. And there is, in fact, that is something that actually happens. Our senses are limited. We see very little. But what we do see, we have to factor out a huge amount of stuff. Otherwise, it doesn't make sense. You know, like when a person is blind, for example, and suddenly regains his sight. All this stuff comes in. It takes a long time, if ever, that he can comprehend what's going on. So, and I want to, this connection, I want to refer to a wonderful author. It's Jorge Luis Borges, who has written a short story, many short stories, but one of them particularly relevant to this topic. It's called Funes el Memorioso, which means Funes, the wizard. Memorious is a word, English word? Okay.
That's the title of it in English.
Okay. So this short story is remarkable, I think, very remarkable. It has many interesting things. I'm not going to go into it too much except to summarize 2 points. Well, Funes is a man who is involved in an accident, horse riding accident, and becomes completely crippled. But however, after that, he somehow remembers absolutely everything. He knows everything. So, for example, if he sees a leaf, he remembers immediately that he saw 10 years ago, he saw that leaf in some woods, and he knows all about it, and so on. And if he sees a dog, say at 3:14 in the afternoon, he sees a dog, and 3:15, he sees the same dog, but it's very hard for him to see that it's the same dog because he knows that at 3:14 he saw him looking at his profile, and by 3:15 the dog had turned, and then it's a completely different thing to him because he notices all the details. And there are many interesting other properties that this complete recall has. But I think Borges summarizes it in one sentence. He says, to think is to forget differences, to generalize and to abstract. So I think this forgetting of differences is absolutely a kind of a censorship that people have, and that's absolutely essential for any kind of comprehension of reality. So that we are in the following situation, I think. First of all, there are things that we think we know. Then there are things that we actually know, and then there are things that are real somehow. And these three concepts are, for many purposes, the same, but for really understanding the limitations on these concepts are going to be quite different. And I asked, we have a privilege here to have a person who is an expert in demonstrating these differences. And so I asked him to give a very brief demonstration before I open the thing or a brief demonstration of these differences. And it's Mark Mitten who will show us something.
Hello. So I'm Mark Mitten, and I do magic tricks. And so one thing to consider, we always think about how people see things. So there's limits, and there's then the limits that you see, and they're not necessarily the same. And so I always like to think about David Hume, but you can't do that quickly, so I use this kid's trick. So what Hume says in the Treatise for Human Understanding is that the need to see cause and effect is psychologically necessary, but not a logical consequence necessarily. So you can take it farther and farther with what appears to be a direct relationship, and you end up looking at the mystery.
So that is my point, and I want to. Okay, now I'd like to open it to our distinguished panelists, and now Professor Rovane has told me that she feels that she's surrounded by mathematicians.
Yes.
And therefore, I would like to give her the floor. And I was told to point to you so that you can be photographed. I would like to give you the floor and say something.
So I wasn't sure how long to go on, because if you invite a philosopher to talk, you might regret it. And so I'm going to try to make my remarks brief, but if people are interested, I'm happy to expand them. I thought the most useful thing today, from my point of view, would be to bring to your attention an interesting interchange between the philosopher Colin McGinn and Noam Chomsky. Can everybody hear me? I can hardly hear myself, so, okay. No, okay, is that better? Yeah, all right. So Chomsky, you may all know, has offered us the idea of a mystery, which he distinguishes from a problem. And he thinks that mysteries are, in principle, unsolvable by us, and he thinks it's within human capability to frame questions that is beyond our capability to answer. This is part of his view. And Colin McGinn has decided to sort of co-opt Chomsky's view in order to explain why philosophy is useless, citing all of the problems of philosophy that have engaged philosophers for centuries as things that we can predict will never be solved because of Chomsky's vision of what we're like. Okay, so what's interesting is that one of the problems that McGinn cites is the mind-body problem, and yet Chomsky has spilt a lot of ink explaining why he thinks there is no such thing as a mind-body problem. So it's sort of an odd interchange between the two. Now, along the way, one of the things that I found most interesting in Chomsky is that he didn't develop the idea of a cognitive limitation just because he thinks we should be modest. You know, we're not the measure of things. Reality is mind independent. We're essentially limited, so why should we think we could know everything? It's not just that. He has a very interesting idea, which is that cognitive abilities are essentially limiting because every ability is limiting. It's not just a point about cognition. The idea is, if you're suited by an ability to do something, the very way in which you're suited to do that thing will make you unsuited to do other things. And you can take motor abilities as a very interesting illustrative case. So if you can slither like a snake, you are thereby unfit to jump. Okay? If you can respirate in the air, you're unfit to breathe underwater. And this is true even of amphibians, who start out as tadpoles and breathe in the water and later breathe in the air, but they don't do both. Okay. So Chomsky's idea is that cognitive abilities are biologically based abilities that should be modeled on motor abilities and other things. And if they suit us to do some things, then they will make us unsuited to do other things. And of course, he was particularly interested in the fact that it's very easy for human beings to acquire languages, human languages. And he thinks that that could be very hard for a different kind of creature, impossible for another kind of creature. But now here's the twist. He also thinks that the very thing that's easy for us not only is hard for others, but makes other things hard for us, right? And he thinks that there is no objective answer to the question which things are hard and easy. There are only relative difficulty and easiness depending on what your abilities are. So it's hard given your abilities or easy given your abilities. And one thing that I thought might be useful to share with you today is the idea that entails that a certain kind of philosophical conception, which is associated with the idea of God, which you all heard about last time apparently, that you can't make sense of the idea of a total point of view. And I'm going to coin a phrase, the point of view from everywhere. The point of view from everywhere would be a point of view from which everything that could be known from every other point of view could be known together. Okay? And to imagine such a thing would be like imagining an agent who could perform every kind of motor task that every other kind of thing could perform, whether it could fly or jump or swim or, you know, it's just nonsensical. And he thinks the same thing is true of cognitive tasks. And so this idealized conception we have of an omniscient being or a superknower, all of these things have to go by the board. In a way, this is an obvious implication of the idea of cognitive limitations, but it makes it really graphic, the idea that a view from everywhere can't be made sense of. Now, the mind-body problem is generally thought of as a view as generated by the disparity between the idea of a point of view and what you might call a view from nowhere, right? The perspectiveless universe, and how does it accommodate these points of view from which conscious states are apprehended? And Chomsky's picture is that is not a problem because we have not sufficiently understood that our notion of body and physical reality is so plastic that we can hardly ever predict which ways in which it could be pushed in order to accommodate other phenomena, including the phenomena of consciousness. And his reservation is, of course, that it will never accommodate the idea of freedom. But consciousness, he thinks it could accommodate. So, thank you.
Maybe, let's see, who would be a good person to comment? Maybe Professor Nelson? Nelson?
I'm still thinking in what you said because much of it is new to me, and so I don't have a direct response or a challenge. It's very interesting. I know that there are intelligences in the universe which have knowledge that is close to us, that is beyond our ken, because once I was hiking along the Appalachian Trail, and another hiker had a dog, and this dog was in a cognitive frenzy, sniffing the ground. Who knows what knowledge this dog was obtaining, but it's something beyond human knowledge. As to what you said about some things being difficult from one perspective but easy for another, I don't think you were saying that it's not the case that some things are intrinsically harder than others. Or
That's Chomsky's view.
That's Chomsky's view. Well, our security of communication is based on the idea that factoring numbers, for example, is intrinsically harder than multiplying numbers together. There's no proof of that mathematically, but there's certainly a wide belief among students of computational complexity that it does make sense to say that some problems are intrinsically, no matter who or what is attacking them, intrinsically much more difficult than other problems. And I certainly believe that's the case. But you say Chomsky would differ.
I think Chomsky, well, one thing that's curious about Chomsky is that he thinks about lots of different species besides the human species.
Mm-hmm.
So when he's thinking about what's an objectively hard problem, he's going to say hard for who? And all of those differences you mentioned in computational complexity are differences we can understand because we can understand computational systems and work with them.
The thesis of computational complexity would be that for any creature or any machine, these problems would be much harder than certain other problems. That's the thesis.
But what's the definition of a machine? I mean, that's a kind of knower in Chomsky's view that might be different from...
anything imaginable.
Anything imaginable?
Anything imaginable.
As opposed to simple recursive
denizens
structures.
of fifth planet of Arcturus, whatever they're like, anything. That's the thesis of, as I understand it, of computational complexity. That there are definite objective levels of difficulty.
Yeah, I know he was meaning to be controversial.
Mm-hmm.
Professor Maudlin?
I guess appropriate for the other philosopher on the panel, let me take the exact opposite point of view the first philosopher took. And let me quote Plato, too, because Plato's a good place to begin. Because Plato, in the Meno, a question of cognitive limitation comes up. Because in the beginning of the Meno, Meno's worried about how he can become excellent or successful, or have arete, for those of you who know the Greek. It's hard to know exactly how to translate it properly. And he asks Socrates, well, do people come by this by natural gift or by training? I want my sons to be excellent, to be successes. Who should I take them to learn that skill? And Socrates says, I'm so far from knowing that I don't even know what it is. I don't know what arete is. And Meno's shocked, of course. He says, well, you don't know what success is. It's to be rich and powerful and to have everybody look up to you and so on. And Socrates says, Meno, you're so wise. Please define arete for me. And in the usual way, he offers several definitions, which Socrates then destroys. And then there's a very interesting point, because Meno says, look, I just don't know what to say anymore, Socrates. I don't know what it is. And Socrates says, well, I don't know what it is. Let's talk about it. And And Meno's response, of course, is, oh, we're a bunch of idiots here, right? I don't know, you don't know. What's the point of continuing the conversation? And this leads to sort of a really critical point in the Platonic dialogues when Socrates then goes on to do a math problem, as a matter of fact, to demonstrate that a slave who's never been trained in geometry can nonetheless come to appreciate the correctness of a particular question about how to build a square with twice the size. And it leads to the Platonic theory of reminiscence. In any case, Socrates at the end of this demonstration says, I don't know if everything I've said is right, but I do know this, that there's the lazy argument, because Meno has given Meno's paradox. He says, look, if I don't know what it is, if I don't know what virtue is, if I don't know what arete is, even if I should run across it, even if we should happen to give the right definition by accident, how would we know? Right? How will I recognize that I've got it right? Because I don't know what it is. And so Socrates does this to say, well, actually, there are cases where you start out not knowing the answer. By hard thinking, you can not only come up with the right answer, but know that it's right by a proof. And Socrates says, you shouldn't believe the lazy argument that tells you not to look. And of course, it leaves open the question, how far can we get? And this is sort of one of our questions of cognitive limitations. How far can we get by thinking clearly, by trying to be as accurate as we can, by doing as many experiments as we can? And even if we can't prove we can get as far as we'd like to, or we can get everywhere, we shouldn't stop until we hit a wall, right? You shouldn't be convinced by someone's abstract argument that there's a limitation. You're likely to stop looking too early. So I'm very suspicious. I don't find Chomsky's argument at all compelling to say if I can do one thing, it therefore follows I can't do something else. That just strikes me as being sophistry, quite honestly. Now, there's an interesting question, how much we can know about the physical. I mean, we have several questions on the table, and people can take up what they know. There's the mind-body problem. So if we know everything about the physical world, would we then come to understand why there's consciousness, why there's a mental world at all? There are some people who think physics just doesn't have the resources to answer that question. There's the question of limitations of physics itself, right? Can we ever come up with the right theory, or are we just not smart enough? This is Steven Weinberg's problem. It's like trying to teach classical mechanics to a German shepherd. You just can't get it, right? But we've been very successful somehow with physics. I mean, continue to be very successful in at least producing a physics that works tremendously well. To know about the physical world, we have to interact with it in certain ways. And we can only find out as much as we can find out that those interactions allow. So physics itself can put limitations on what we can know about the physical world, right? You can sort of see that the physics of the world might not allow us to know for sure what the physics of the world is, which is a very interesting situation. And you can talk about cases like that. And then there are other cases, I guess, that people here have thought about the limitations of mathematics, because we use mathematics as the language in which to state physics, so limitations in mathematics or our mathematical understanding could lead to problems. But I guess, I think these are all individually very interesting questions, but I do want to push back against the idea that there's some obvious reason to see that we're going to bump up against some wall we can't get beyond. We might. I mean, we ought to keep that in mind, but I don't see any reason to convince ourselves that we're perpetually limited with respect to the things we want to know.
Chaitin.
Okay. My field is pure mathematics, and that's a toy world, right? That's the Platonic world of ideas. This is much easier than the real world, or certainly than philosophy. But there is a very deep result in pure mathematics from 1931, which is Gödel's incompleteness theorem. And this theorem sort of says, it's a meta-theorem, it's a limitative theorem. It says that there is no single theory of everything for all of pure mathematics. And this result was viewed as, I think, rather shocking originally, because it's a limitation result. It says you cannot have people sort of assumed that you could have a sort of Euclidean geometry for all of mathematics. Zermelo-Frankel set theory with first-order logic is the most popular candidate. And this would be a axiomatic theory with rigorous logic from which you could deduce all truths and only the truths of pure mathematics. And Gödel in 1931 shows that this isn't possible. And this was regarded originally by a lot of people as a very depressing limitative theorem, saying if you can't have a theory of everything in pure math, which is the world of ideas, what's going to happen in the real world or with more difficult disciplines. Now, I've spent many years worrying about Gödel's incompleteness theorem, and I think the traditional viewpoint is wrong. At least I'm trying to explore a new viewpoint. And the new viewpoint is that Gödel's incompleteness theorem is wonderfully good news, not bad news. And the reason is, since we're in a center for imagination, and originally it was creativity, I understand, the reason is that, you see, if there had been a theory of everything for all of pure math, mathematicians, in a sense, would just be machines that could automatically grind out all of mathematics slowly, but in principle it would be possible. And what Gödel incompleteness tells us is that something mysterious called creativity is essential in pure mathematics. At least that's one interpretation, which I now feel is a better interpretation. So, in fact, what I think is that this limitative result, which originally was viewed as very pessimistic, what it's really doing is opening a door, I would say, to creativity. And in fact, Emile Post made remarks like this in I think the 30s and the 40s that nobody paid attention to. And creativity is a very difficult subject. So this is not a new idea, but I think I found a new way to try to develop it. And the problem is this. There is a beautiful theory called Darwin's theory of evolution. And as a pure mathematician, as a Pythagorean, I find it unacceptable that there isn't a mathematical theorem saying that the theory of evolution works, a simple mathematical theory of evolution. So I've been actually trying to use Gödel incompleteness to show that evolution will work, that there is room for biological creativity to go on forever. And the way it works is really very simple. To give you the general idea, there's a mathematical, I have a small mathematical theory, a new theory about this, but the basic idea is that my organisms are sort of mathematicians. And I challenge them with a very difficult mathematical problem, a problem that is so difficult that Gödel incompleteness applies to it. So there is no final solution to this problem. So my organisms can get better and better at solving this problem, but they never get a final solution. They never get a theory of everything. So they have to keep evolving. And so this is a little theorem of mine. This is a toy model where I can prove that things will evolve. I have a kind of a very toy version of Darwinian evolution. And I admit it's just a toy model, but you see, I think there is something that has gotten lost in the discussion, in the discussions, the mathematical discussions of Darwin's theory of evolution, which is biological creativity. The current version of that is called population genetics, and it basically says that a system that a population adapts to the environment that it's found in until it's perfectly adapted, and then things stagnate. And I would like a theory which says that biological creativity will continue indefinitely. There's something called the Red Queen hypothesis. For those of you you have to run as fast as you can to stay in the same place. And so what I have is a version, a new kind of toy model of evolution in which biological creativity is possible. Because in standard population genetics, you cannot discuss where new genes come from. And I have a toy model of random walks in software space, life as evolving software, which in a sense builds on Gödel's 1931 work and Turing's 1936 work, and uses incompleteness as something good rather than something bad. So I think limitations are actually good, not bad, because there's something we can fight against, and they give us room for creativity.
Well, I think my role here is to call on people, but I
No,
can't
you don't have to. You can participate yourself.
I have to just ask one embarrassing question here.
Sure.
My understanding of Gödel's incompleteness theorem is that there are propositions for which there is neither a proof nor a proof of their negation. So how can you talk about making progress on such a problem?
Well, a technical answer would be you can just add the thing that you normally prove you can't prove is the assertion within the system that the system is consistent. And what you can do is you can just add that as a new axiom, and that way you can extend the original system.
You can just add the proposition which is independent as a new axiom.
Right. And
that's progress?
Well, Turing has a paper in 1938 studying. You can continue that process into the transfinite, and you can.
I just wanted to call attention to this.
Sure.
Maybe anybody else?
I think that Gödel,
or add new axioms, or add new concepts to your theory.
Right.
I think that the Gödel incompleteness theorem has had little effect on mainstream mathematics. For example, Harvey Friedman has been working for years to create natural-sounding problems, which you can prove are undecidable, but I don't think with much success. And,
well, I can give you a natural-sounding problem. Right?
And I think that that Hilbert, even though he got carried away and wanted to prove that everything had a solution, I think nevertheless he had the right attitude. On his gravestone is inscribed, "Wir müssen wissen, wir werden wissen." We must know, we will know. And I think that this is the spirit with which creative mathematicians are imbued, that the problem may seem difficult, but let us work hard, let us solve it. We can solve it, we will solve it.
Can I just make a little comment here? Because I actually also agree. I don't think Gödel's incompleteness theorem is terribly relevant. There's I think a mistaken idea when you talk about mathematical truth. Of course, there's a lot of mathematical truth, tremendous amount of it, as if it's all interesting. There's a whole lot of mathematical trivia. Let me give you a very simple kind of thing which will illustrate, without going into complexities, the problem of decidability. So, if you take any number, the square root of 7 or the cube root of 84, and you can write it out and you get a nice decimal expansion that'll go on forever. So I hand you two of these. I say, take the cube root of 87 and the 27th root of 58. And now ask yourself, you now have this nice expansion in decimal notation, and let's say these two decimal numbers match if the following is true. Either their first numbers are the same, or the next pair of numbers are the same, or the next triple, or the next quadruple. If any of those do, then they match, and otherwise they don't. Now, I can start calculating out, get a computer to start calculating these out, and check as far as I like. And if they do match, at some point that computer will find this match, and it'll stop, and it'll say, these match, right? Because I just found 105 of these digits that are the same. And if they don't match, the computer will just keep generating forever. It'll keep checking and checking and checking and never stop. And it's a mathematical fact that it'll never stop. But now you can ask, but could we prove it'll never stop? I mean, it's easy to see. If it will stop, I'll eventually know it'll stop. Will I ever know for sure it won't stop? Now, for every pair of numbers I pick, I can ask this question. And it's just not an interesting mathematical question, right? It depends on using base 10. I can use it for any pair of numbers. All of that's mathematical truth. Now, if you tell me, gee, there are a bunch of facts like that we can never know, namely that these never match, right? Because I can't ever prove it by computation, what makes me think some clever mathematician is going to come up with a proof for every random pair of numbers I pick? It doesn't bother me, right? Okay, of course, there's lots of mathematical truth out there that's beyond our ken. The question is there interesting mathematical questions? I think this comes back to it. Are there what we think of as interesting questions? And also, even in the case of finite, this idea that if there was an algorithm for generating it, then mathematicians would just be grinding out answers. Well, and this is now to make a point that was made before to me by Professor Kohn. Chess is a finite game. So you could say, well, isn't it then aren't chess players in principle just going to be grinding out chess? And the answer is no. They have to be tremendously creative, amazingly creative, right? again, because of our cognitive limitations, we can't see the entire decision tree for a chess game. So the only way we make progress is by having clever strategies and seeing deeply into the game, unlike the computers that just get better and better at doing long-term searches. So I don't see that even if there were an algorithm that would produce all the answers eventually, that would somehow kill off the idea of creativity, because we want insight, we want understanding, we want elegant proofs, we want to feel like we know what's going on, not just decide that this is right. So I'm again...
Well, I certainly, again, stepping aside as moderator, I'll make a comment. I certainly agree with you on your conclusions, and I think one of the most convincing thing about this is that obviously literature is creative, but there are only a finite number of books that could possibly be written in the history of mankind. So in some sense, you could just grind away and throw away the things that you don't like, and a completely mechanical process. So I don't think that's... But nevertheless, I do think that Gödel's theorem is some kind of very important thing. I mean, the idea that followed up by the proof that the axiom of choice is independent and things like that. And actually, Gödel himself was a Platonist. I think he would agree with Hilbert.
So.
With Hilbert on the idea that that there must be a proof and so on. It just shows, the incompleteness theorem just shows that our methods of proof don't reach as far as Hilbert might have thought they did. But the idea that we can't explore things, and as Professor Chaitin points out, you can add axioms which are compelling, and if you want to understand things better and so on. So,
right, but let me just make a small comment.
No.
As Professor Chaitin said, Gödel showed no consistent system can prove its own consistency. Right? And you might say that's a real worry. But on the other hand, if you were worried whether the system was consistent, you wouldn't care that it can prove its own consistency, right? Suppose I start out worried. I'm not sure if I'm dealing with a consistent system here. Right. And in fact, it grinds out the result. I am consistent. I don't know whether to trust that result because I didn't know whether the system was consistent in the first place. So,
sure.
It's an interesting observation. I mean, the beautiful thing Gödel did was show how to construct a mathematical claim given an certain kind of algorithmic system, which provably, if the system's consistent, it can't prove. It's true and it can't prove. So it was a demonstration of a limitation we should have expected all along. I think we should have expected limitations to our ability to prove mathematical truths from very trivial observations. That's all.
Sure. I'd like to add something to what you were saying a few minutes ago, that one example was Fermat's last theorem, which seemed like an isolated puzzle of no particular interest. It was only when Freud joined it to mainstream mathematics, theory of elliptic curves, that Andrew Wiles, with help from Richard Taylor, was able to solve it. And also, I remember when I was a graduate student, I was at a party that Professor Chern gave for Donald Spencer, who had come from Princeton to give a talk at the University of Chicago. And Don Spencer was a very enthusiastic person, and at the time he was interested in the following question: does a six-dimensional sphere have a complex structure? Well, that didn't mean anything to me at the time, but talked about it all evening. And finally, he asked Chern, what do you think? Does the six-dimensional sphere have a complex structure? And Chern's answer was, it doesn't matter. Now, but you don't take that on face value. It matters very much if we can prove it or not. It's the essential thing in mathematics, in my view, and I think of most practicing mathematicians, is not knowledge, it's not truth, it's proof. Can we construct a proof? That's been the tradition for 2,500 years, ever since Pythagoras. And I think it's maybe a historically contingent fact that on this planet a community developed in which we were not interested primarily in whether something is true, but whether we can demonstrate that it's true. And that is, to my mind, the heart and the beauty of mathematics.
I'd like to make a couple of short comments on what you said. One is a historical comment about Professor Chern. Now, Professor Chern was a wonderful mathematician, and he lived to a very old age, in his 90s. And towards the end of his life, he became obsessed with this question about whether a six-dimensional sphere has a complex structure. And he felt he had a proof, which people were very dubious about. In fact, it was wrong. But his prime student, who is Professor Yao, of course, the Chinese press, I mean, in the United States, nobody would care. But Professor Chern at the time was in China, and the Chinese press was all over that Professor Chern has solved this question about the six-dimensional sphere. And when Yao arrived in China, they asked him, what do you think about the solution? So he took out, he said, I can't comment on this directly, and he took out a piece of paper in which he had a statement worked out, where he said something like, Professor Chern is a great mathematician, he was my teacher. And for a person at that age to be able to even think about such a difficult problem is a remarkable achievement. That was the, and just in order to, excuse me for wasting your time a little bit, but it just reminds me of a Jewish joke, which is that the rabbi of some little town in Poland suddenly stops in the middle of his prayer and said, my God, the chief rabbi of Prague has a convulsion and he's dying, he's dead. And everybody stops and he sends a delegation out to the funeral. His assistant there is telling this with great admiration to assistant of some other rabbi who are arguing which rabbi is wiser. And the guy said, well, the delegation, what happened? They came back? Yes, they came back. And what happened? Well, it turned out that he was alive. Nothing had happened. So what's so great about it? You don't understand. It doesn't matter whether he was dead or not, but to see that far. So I think there's some analogy about about those theorems that are it's just a proof, you know. So, but anyway. So just as long as I'm stepping out of my role, I should also make a remark about Fermat's last theorem. Of course, Fermat's last theorem, as it stands, is just one of the many possible things that the Greeks left open for us to work on. But the interest of Fermat's theorem is that it gave rise, people got fascinated by it because it's such a hard problem, and it gave rise to very important ideas in mathematics in the 19th century. And I think that's why there was so much interest in it. I mean, the theory of ideals, which is an absolutely foundation of modern mathematics, came about because people were trying to, Kummer especially, was trying to solve. In fact, he thought he had a solution for Fermat's theorem, and then it turned out that he didn't, but he manufactured a huge number of situations where it is solved, and the theory of ideals took off, and practically that kind of reasoning took over mathematics, and a huge revolution in mathematics. So, of course, I'm a great admirer of my colleague, or ex-colleague, Andrew Wiles, but there's a long history of wonderful things that the Fermat's last theorem led to. Yes.
Can I go back to limitations?
Certainly.
Yeah, okay. Let me give you a more modern version of incompleteness that is not at all like the traditional one, and may have some appeal perhaps for psychoanalysts or things like that.
Oh, that'll be good.
Yeah. So it's a different version. So here's how it goes. You take a mathematical theory, axioms, rules of inference. It's a closed logical structure. And the normal proof that there are things that are true but not provable within such a system involves self-reference. I'm unprovable, an assertion that says I'm unprovable. Okay, that's great. It's a logical paradox. Mathematicians love it. It's a well-developed theory. However, here there's a new approach which uses the concept of information. And it basically, I'll give you an intuitive version. It basically is like this. You can measure how many bits of information, how much complexity, measured in bits, in 0 and 1s and yeses or nos, there is in a mathematical theory. That's the information content, technically the algorithmic information content of the axioms plus the rules of inference. And that gives you a measure of how much information there is in your mathematical theory. And the idea is that the world of pure mathematics contains an infinite amount of information, has an infinite amount of complexity. And any particular formal axiomatic theory, mathematical theory, can only have a finite amount of information. And this is a newer way of seeing that there is no theory of everything. Because if you have an infinite amount of richness in the world of pure math, and any theory is only can capture a finite part of it, then it's sort of natural that your theories need to get richer and richer if they're going to cover more and more of your mathematical experience. So another way to put this that may sound a little more psychoanalytic friendly is that there is a sort of a maximum complexity that a pure mathematician can deal with. Perhaps the human mind is only capable of handling a certain amount of complexity, and there may be limitations because there may be theories out there that are richer and more powerful than the ones we have, but they start getting so complicated that it's more information that can be contained in the human mind. So some people, so this is a sort of a new flavor of incompleteness that has come out by using something called algorithmic information theory that I thought I might throw on the table and see what rotten tomatoes you can throw at it.
Maybe Professor Rovane would like to come in and swipe some of this mathematics to the side and say something.
I think I wish Noam Chomsky were here, because I think I try to imagine what he would say in response to the quick resistance that my report of him met on the part of Tim and Edward. And first of all, I think that Chomsky would never say, stop inquiring, be lazy. That was not the point. In fact, he really poo-poos philosophers who think that there's no scientific or philosophical way to think about lots of problems that philosophers are prepared to say are insoluble, the mind-body problem being a case in point. And I think it was more, and the reason I raised him was more in the interest of his effort to bring out the danger of a certain kind of anthropocentrism or egocentrism when we think about minds. I mean, that was really the thing that interested me. And I think his challenge to the idea that things are objectively simple and complex, or objectively hard and easy, not relative to a particular cognitive constitution, is a very interesting one from this point of view. And so I would like to press again, when you say computation theory, says some things are objectively harder and easier, but that's a very specific paradigm of what a cognitive constitution might be able to glom onto, is what things are computable in that sense, and what things computation theorists will classify as hard and easy. And he really has the imagination to think that that's very human specific, that idea, the ways we think about that. And so he would say that that's all relative to a bunch of abilities we have to set up structures that we can understand. I think that would be the spirit in which he would argue. And it's not to say that we should start trying to understand things we can't understand, but rather to concede something about what it is to be minded. You're a reflection of the world, but a very, very organized one that makes you unable to glom onto the things your organization doesn't mesh with very well. I think that was the idea that got lost here. But it's off to the side. I predicted this, as I told you at the beginning of the session, that there are mathematically inclined folks, and then there's
the philosopher
who isn't.
I seem to, I was in Cambridge when Chomsky was doing this wonderful work, and I went to several of his lectures and so on, and he seemed to be very mathematically minded to me at that time.
Of course he is.
And I think that this argument that Ed makes would resonate with him, and he would have to answer it somehow, because certainly it's true of complexity theory that there are very objective ways of saying that some things are harder than others. I think,
For what kind of system, though?
Any system.
But what is a system? What is a system?
Well, whatever. Suppose you have something that takes a certain. You have some kind of process that takes a certain number of steps to resolve, and then you have some other process that takes a hugely larger number, and this is all. We are thinking here about infinitely many processes of these two different types, and so it's natural to think that no matter who is, you can take the system and the machine out of the question. Ed is much more knowledgeable of these things than I am, so
maybe I should
really
clarify. Supposedly, this applies to any physical system, any machine we could build. That would include us, computers. Supposedly, this is what computational complexity theory attempts to do, to give some kind of absolute measure of difficulty of a computation. Supposedly. Now, the interesting thing is that there was a surprise in this theory, because we were using what are sort of now called classical computers. And now there's something called quantum computing. And all of a sudden, it turns out that things that we thought were difficult, it turns out quantum computers that use quantum mechanics rather than classical physics can do them much faster. So the point I'm trying to make is that this computational complexity theory, in a way, is a kind of a theoretical physics. The assertion is that what is difficult or easy depends on the physical universe you're in. And what's sort of happening, interestingly enough, is a kind of a convergence of theoretical computer science with theoretical physics in the field of quantum computing and quantum information theory. And I think the fact that complexity theory has now turned in a quantum direction and the difficulty of things has changed, I think makes a point that this is dependent on the universe you're in, the physics of the universe. But you're trying to look at all possible physical systems in that universe, which would include us, would include other biological organisms, and would include computers. But this theory shouldn't be too smug about what it's achieved, because just a few years ago, everything changed.
Okay.
And it doesn't exclude looking into a crystal ball and reading the answer off from that.
If crystal balls are physical systems, yes, in our universe, yes, that doesn't exclude.
It's a scientific hypothesis, so it's subject to empirical refutation if there's some process that no one has envisioned and gives correct answers to problems thought to be difficult. That's irrefutable.
Right, but you do see in this how, your original point with the dog was that the dog, because of his sensory constitution, which is different from ours, had different access into physical, what had been going on in the world in that particular area over some time. The suggestion, if I understand it, of Chomsky is that we should think of all of our cognitive capacities rather similarly, that we develop some, right, just as we have different nasal capacities or olfactory capacities, right? But what we've seen is at least the line of an answer that says, no, all of these systems are physical systems. Mm-hmm. There's the physics, that's a constraint. There's evolution, that's a constraint. Could you evolve a system which, as it were, found it very easy to extract square roots or cubic roots and hard to add, right? That somehow the one procedure it could just do intuitively and transparently, right? You give it 854 and it just comes back with the cube root, but you say, what's 1 + 1? And it goes, oh, God, first I have to take the cube root of this, and God knows what it does, some very complicated thing. It just may be that physically you can't do that. Somehow the physical capacities needed to extract cube roots, you have to put together, given our physics, a much more complicated system that will have to add and do a bunch of other things in
But I
the
just
way.
say, though, it's so interesting that you pick a mathematical case, because I think Chomsky would see mathematical abilities as highly specific, and that there is an interrelation between the capacity to count and the capacity to compute square roots wouldn't be very interesting to him. I mean, I think he really invites us to think about rather different cognitive problems than the ones we solve with mathematics in that particular way, by using rules and proof, the things we like. I mean, anyway, it's just pushing on the point that if you analogize cognitive capacities with motor abilities and other things, this confidence that the sets of rules we're comfortable with by which we prove and think these things and physical possibilities are really exhaustive of mindedness.
Right.
And I just found that interesting and seemed germane to the topic. But I'm not equipped to press his point of view. Okay.
But I don't think anyone here thinks that things are exhaustive, right? We all understand there are limitations, cognitive limitations. To me, and maybe this is appropriate for psychoanalysis, is what's your emotional reaction to that, right? I mean, it means, in principle, you could spend your life trying to solve a problem which you're fated never to solve, right?
That's the psychoanalyst.
Right, and exactly right. So you sort of look back and you say, my whole life was spent banging my head against this particular wall, which wasn't going to crack. Right, I wasn't going to get through it. And I guess the point at the beginning I said is, but we don't know beforehand which walls will crack and which ones won't. And I guess we just have to accept with a kind of humility, maybe that's what I'm doing.
Yeah.
But I don't know, and I'm just going to keep banging my head against it and cross my fingers. And maybe it'll crack. I just don't see any other way out of it.
So
is that a tragic view of life? I don't know.
You have to take a risk.
Seems where we are, right? That's.
You have to be a risk taker.
Yeah.
So where does it stand in terms of limitations or no limitations?
I think it's clear there are limitations, and it's clear we don't know what they are.
Right.
And given that situation, we press as far as we can in every direction we can. And if things get tough going, you keep in mind maybe you can't get through it, but
I would say, but even if there weren't these theoretical limitations, there certainly are limitations. Right. There are problems that are longer than the seconds in our lives and stuff like that. I mean, so we're up against limitations no matter what the theoretical setup is.
But in terms of explanatory mathematics explaining or physics explaining everything, are there limitations there?
Of course.
What?
I mean, well, first of all, there are. I think that there. No, let me say it this way. As I try to say in my introduction, I think there are limitations to our very knowledge of anything, so that that a priori puts limitations on everything, on any kind of complete explanation and so on. Just the way.
But historically, there hasn't been limitation in the sense that we know more and more and more and more.
Right. But
is there a point where we cannot know anymore, aside from when we die? I mean, for people who are still going to be alive, is there a point where you can't know anymore? Is mathematics going to prove that there is a point, or mathematics cannot prove that there is a point where you can't know anymore?
Well, I think you can certainly prove that there are problems which takes longer and longer times to solve, so that you will never. If it takes maybe 10 million years, if we can prove that there's a problem that will take 20 million and so on. So in that sense, I think there's.
Isn't there something you mentioned fullness? Fullness is a man.
Right.
I mean, the whole Ed mentioned God in the beginning.
But I mean, the mention of fullness was to. My interpretation is, as I quoted from Borges, is that is a different kind of limitation. That seeing everything is still a limitation of what you can understand.
Well, what I mean is positing the heart of the whole discussion here is the notion that we all have a perceiving creature who's basically anthropocentric. I mean, if you're going to consider computation, must it always be from the point of view that we have a subjective observer who's a man,
Well, my answer to that would be yes, but I don't know. But there's a philosopher's take that up.
I'm worried about the limitations on human beings from a purely, self-interested point of view. I'm not worried about the cognitive limitations on deities. But I mean, let me just make another. I think the worry about limitations is a little bit misplaced in another way. Because even things we know, even things that have come within the scope of our knowledge, you can have deeper or more elegant or clearer understanding of. There's a wonderful example, one of the early computer programs that they did that was supposed to do geometrical proofs algorithmically. They gave it the problem of proving that the angles in an isosceles triangle are equal. And usually this is done with the pons asinorum. I mean, I don't know if you all remember the sort of fancy construction that looks like a truss for a bridge. And the computer proved it in a much more elegant way. It actually didn't have to construct anything.
That's the way Euclid did it too, by the way.
Is that?
Yes.
But a lot of people at that point said it never occurred to them, right? That you essentially proved that the triangle is congruent to itself flipped over, okay? And you get this immediate proof. Now that's elegant. It's beautiful. It's not new knowledge, right? We already knew it, but gee, you feel like, I learned something today nonetheless. So even within the ambit of things we know, I think what are the limitations of how deeply we can understand it, or how elegantly we can understand it? I mean, the idea that there might be some algorithmic limits way out there somewhere, I think our life isn't lived there. Our life has a lot. I mean, we're never going to end. You're never going to end up saying, "Gosh, what's the point of living? I've learned it all, right? And I've hit the wall."
I've hit the wall many times, but I keep going.
Anyway, you asked if math has a proof that there's a wall, right? That there's a limit. The way it works actually is the way you prove that there's a limit is by exhibiting something that is true but you can't get to. In other words, you go past the limit. You exhibit something which goes beyond the limit. So there's a paradoxical nature to all the limitative proofs in mathematics, in that they, in fact, are showing us stuff beyond the limit. So in a way, the proof that shows that there's a limit, in fact, is going beyond the limit by exhibiting something. So in other words, it's showing us how to progress, that there is a way to go beyond.
I think there's an assumption that many speakers here have made that I do not share, namely that there is a meaningful concept of truth in mathematics. I think it's a delusion, and what is real in mathematics is the proof, the demonstration from certain assumptions and certain rules of inference. But to say that a mathematical assertion is true or false when it deals with the hypothetical infinite structure, I think is devoid of meaning.
So you're a formalist, not a Platonist.
I'm a formalist. Maybe the philosophers would have something to say about this.
I'm a Platonist. I'm a Platonist, so I'm not. I mean, I guess we know what the.
Well, I'm inclined to formalism too.
You're inclined to formalism.
There's no standing to have a view, but it is my inclination. But going back to something Tim just said, it strikes me that mathematics likes linear forms of thinking, whether they arrive at knowledge or just provability. Mm-hmm. It doesn't matter for me, from my point of view. And yet what you were talking about really is, when you mentioned coming at the same point in a new way, strikes me as more interesting when you think of holistically connected bits of information in a belief set, because coming at the same thing, the very same thing from another angle, is almost not coming at the same thing, and yet it is at the same time. And that is a kind of inquiry I don't think you can ever be done with, though it could suffer from some of the same problems of not always being interesting, like your very long decimal expansions. But even so, I think it does make the question of limitation seem not germane to lived cognitive life.
Right.
Yeah.
You want to take it to the audience?
Yeah. Well, I think perhaps we can now have the audience ask some questions maybe or make some brief statements. One?
You got to come up.
Yeah.
You always have trouble with the mic.
Will you pick people? So oh, you are the audience, right? Go ahead. I thought you were. Yes.
Stuart Dambrot. Is this on? Who knows? Stuart Dambrot, physiological psychologist, scientist, as you'll see in a moment. So I just want more observations that I would really appreciate a response to. One is when I was listening, there is a very prominent common thread to what different panelists were saying. In the representation of Chomsky, talking about an infinite, let's call it an infinite space of ability. And he's making an assertion, it could be said, that there are subsets of that in fact are finite. Well, that corresponds to what was said about the revisiting of Gödel's theorem, in a sense. You have an infinite space, and then you have a finite space in terms of information density or the number of bits defining that space. So there's a certain parallel there. And it also comes into even, in a sense, the humorous comment about psychoanalysis, because, in fact, there are theoretically an infinite number, even though it's a softer science, an infinite potential number of interpretations of a complex of behaviors and symptomologies that, in fact, will devolve, hopefully, to a finite subset of that. So there's a common thread in all this that I just wanted to point out and get some reaction to.
What's the common thread?
That, in fact, that the common thread is an infinite set of some type of entity and then a finite subset that parses into the specific constituents or potential constituents, however that's enumerated. That's one. The second had to do with complexity theory, and it wasn't addressed that there are chaotic boundaries. And on the far side, it's related in some ways, I think, at a deep level of structure to what you're talking about translimit, the translimit function in a proof. That what's on the other side of the emergent chaotic boundary in complexity is not predictable, right, from the starting conditions, the way we can't determine the phase change in water between different phases from the properties of the constituents of the molecule itself. The emergence of flocking behavior in birds and fish is not able to be determined from an exhaustive look at the birds and fish themselves. It's something that emerges across a chaotic boundary. So that's the second part in complexity. And the third is just something that you mentioned earlier on. And I was thinking, no, yes, it is subjective. That's very important. But we can't limit our conception of anthropocentric limitation to our sensory apparatus, because as we expand our ability to investigate levels of scale, our knowledge grows. The question is the level of scale question open-ended, or is there a Planck scale that is a fundamental smaller scale? And those kinds of questions, I think, impinge heavily on the question of the limitations of knowledge acquisition. So those are the three observations. I'd love some responses if you care to give them.
Any other?
Did you want to comment on Stuart's any comments?
Would any panelists like to comment on this?
I mean, maybe this is coming back. It's true there's an interesting difference between infinity and finitude, and there's an interesting difference between different orders of infinity as mathematicians. Yeah. But I guess, again, this is just to maybe repeat what I was saying at the end. My feeling is there's also an interesting difference between really big finite and what we're capable of. And that what we've done so far, what any of us have done in our lives and what we of humanity done collectively is such a very, very limited area of what we're all individually and collectively capable of, that to worry about what's way, way, way out there is to take us away, I think, in my mind, from everyday life, right?
Yeah, from quickly by saying that the concept of really big finite is notoriously fluffy, in a sense, and that in fact what is notoriously big is a relative statement, right? For an individual 2,000, 3,000 years ago, the challenge of coming up with the epigenetics of our genome and genomic behavior would have been a very big finite question.
Sure.
It's much smaller now, relatively speaking.
Right.
So I don't think you can make absolute statements like that in a philosophically meaningful way. That's just...
I would like to debate that a little bit. Of course, you're right in some sense, but in the other sense, there are things that are so... Let's put some limits on it. Say we're talking about the next 1,000,000 years, and we take, say, the number of seconds in the past 100 million years, and you take steps that take at least a minute to take. That number is too big to meaningfully talk about. It's still a finite number, and you can say more or less what it is, but it's not reasonable to think that such a number is, if something really takes that many steps or something, that such a number would be accessible in the next 1,000,000 years. And I don't think we want to talk about things that will happen past 1,000,000 years from now.
Past does not necessarily determine future. Even in mathematics, discoveries, for example, of the geometric method of essentially transecting a sphere to find a minimization path. That was about 12 years ago. That was not anticipated, and it completely reduced the problem space.
No, I agree that lots of huge numbers of problems which seem untractable will be solved and whatnot. But the fact is that there are things which the fact is that there are things which are so intractable that they can't be solved.
Again, that's a fluffy statement.
No, it's not fluffy. But okay, that's a difference of opinion.
But go to the mic, otherwise you cannot be heard on the tape.
Simple question.
Wait, which mic?
It doesn't matter, but he was standing there at one point, and then you can't be heard.
Everything I said is gone.
It's lost. It's lost. Not everything.
Go into
Right.
Go into psychoanalysis, and he'll help you remember it.
Yes.
I'm curious what the panel would say are unanswerable questions. I'm not interested in mathematical ones because that's going to be over my head. But in terms of either physics or neuroscience or consciousness or philosophy, what are the questions that will never be answered, do you think?
Okay, I'll venture a question that's not answered, and that it's not really satisfactory answer. That is, what is beauty, for example? It's very hard to say. For example, there's again a question of limitations. I mean, it used to be thought until the 20th century that art has certain definite rules, the music has certain definite rules, at least in the Western world. And then people started dropping those rules, and there were big controversies whether this is beautiful or terrible and so on. And I think that the experience shows that it's going to be very hard to have a kind of an answer which...
But doesn't the existence of God fall into this category?
Well, to me, well, never mind.
You have already...
I don't want to get into that.
I'll come back to what I said at the beginning, because it was one of the things that was mentioned that we didn't talk about it. There has been the mind-body problem is there. It's been there sort of forever. You go back and read Leibniz, and you go back and read Locke, and is it ever going to be comprehensible to us why any organization of physical matter? I mean, we can have a perfectly good evolutionary explanation of how matter could come to self-organize, become more complex, that you could get things that would reproduce better, that all of that could lead to a structure that then gives rise to an inner life at all. Yeah. To me, I just don't see it's in the cards that we're ever going to understand that. But of course, maybe this is, again, our cognitive limitation, or maybe it's not a limitation, and maybe if someone's clever enough can come up with a whole new set of concepts and a whole new way of looking at things. But at the moment, I don't see any chink of light in that particular darkness.
Okay, can I disagree? I'd like to defend the optimistic view. My optimistic view is that our current science is not even wrong. Another way to put it is the Copernican principle that says we're not the center of the universe physically. Well, I don't think we're the center of the universe in time either. Why should our current science be the final science? If you look back in history, every 50 years or so, there's a complete paradigm shift. A century ago, they had just discovered the electron. Quantum mechanics wasn't known. They still believed in classical physics. If you go back another 50 years, another century, it's another enormous change. So unless the current, grant and refereeing system destroys scientific progress, I don't see why our current science should not suffer the same fate of the science of 50 and 100 years ago. So I think 50 and 100 years from now, unless we're really dummies, science will be unimaginable from the current perspective. And I don't see why consciousness shouldn't end up being something that there are theories about. It may be, why not? Why not? I mean, this is clearly something that doesn't fit in our current system, right? And some people will deny. They'll say that it doesn't exist. I was at a panel where somebody was saying there is no such thing. It's a pseudo problem. Okay, but it's something we all experience and which I wish we could understand. And it's true, at the present moment, there isn't that much understanding. But, look back 50 or 100 years, there were no electrons, there was no quantum mechanics, there were no transistors. So with a little bit of luck, what would science be like 50,000 years from now if it keeps progressing at the current rate? Just a linear extrapolation doesn't have to be correct, but, just as a first cut, let's take that. It would be totally unimaginable to us like magic, right. Imagine Newton coming here, or someone from before then. So, like magic, I think is a very good, indistinguishable from magic, or not even wrong. So I'm hopeful. Unless we're really stupid and, commit suicide on this planet, I think at any given moment, maybe we won't understand everything. Maybe we'll never finish, but I don't see why we shouldn't be able to keep progressing. So far, it's been going rather well, I think. Right?
So I'm optimistic about our capacity to fit a notion of consciousness into a sort of big conception of the world. But I don't think it's a very big portion of our notion of mindedness. I stand apart from lots of people, and it's not because I think of the mind as a machine. I tend to focus more on the idea of a point of view as not just what it's like to feel pain and what it's like to have emotions, but what it's like to be able to deliberate, evaluate, rank options, think about requirements of rationality that you'll never live up to, capacities to think in perfectionistic terms about what you could possibly arrive at or be. I mean, just think of your notion of progress just now, how expansive it was, right? And I think that's very deep in our notion of mind, to think in idealized terms, some critical standard or goal that we inevitably fall short of, and we think of ourselves as limited beings. This is a very Cartesian remark. It's the way he often described us. And I don't really I'm in great suspense about whether that would ever fit into a scientific picture of the larger scheme of things. That's what perplexes me the most. But I would never, as Dewey said, we shouldn't throw roadblocks on the path of inquiry about these matters.
I agree with Tim that I simply cannot comprehend what a solution to how a physical system can give rise to something with an inner life, how that problem can be solved. But nevertheless, I predict that within the next 300 years, there will be a society for the prevention of cruelty to robots, because we will know somehow or other that they're capable of experiencing pain.
Oh, there's a question.
Yes.
Okay. Hi, my name is Olga, and for me it was very strange that there is that's not so much was said about...
Olga, get closer and speak louder.
My name is Olga Ast, and it was very strange for me that I didn't hear more about limitations of language itself. And maybe it's a big problem for me because I'm a person of two languages, and sometimes, not even me, but my daughter who has perfect English cannot say something in English, sometimes very simple for Russian. And we all know that, for example, in Chinese there is like 100 terms for blue, and in English just one. 100, no, not maybe 100, but many terms for color blue. Oh. And in English just one. So, and again, about limitations of any kind of language, not only Russian but also mathematics, seems like we have a success with mathematical language and with production like these things, with which what we are doing, we're just talking about closest sale, yes? What we're doing, we don't do so much. But distraction that we create around us, creating this convenience for just humans, it's kind of not even comparable to what convenience we get, you see? So there is strange optimism about mathematics can solve everything. We cannot solve even being in balance with our environment. So that's probably one of my comments, but
okay.
Thank you.
Greg, you want to comment on?
To defend mathematics?
Optimism issue?
Well, I think Plato is a good defender of mathematics, or Pythagoras. Love and beauty are things that can be discussed, from evolutionary viewpoint, for example. But to give a concrete example, biologists are convinced that Darwin's theory of evolution is correct. They don't think it's a miracle that we're here, that it requires divine intervention. They think we're the product of accident, of random events and natural selection. And they believe that there's adequate empirical evidence, right? And I have nothing against this. I think that's all very splendid. But I'm a pure mathematician. I'm a Pythagorean. I would like to see a simple, elegant mathematical theory where you prove that evolution works. You define life, and you prove that that evolution will work. I would say that otherwise we don't really understand biology. In other words, to me as a pure mathematician, for more than 40 years, I felt that it's sort of a scandal that there isn't a simple, general, abstract mathematical theory that sort of captures some fundamental concepts from biology and evolution. And for that length of time, I was trying to find a path, unsuccessfully. But in the last 2 years, I think, in fact, I do see the beginnings of a theory. And it's a very simple theory, mathematically. I have a very simple toy model. And it's basically the idea of life as evolving software, randomly evolving software. So I sort of throw away the body and only keep the DNA, which is digital software. And so I make a toy model where I take computer programs and I randomly make changes in them. And there's some fitness measure, and you're doing a random walk in software space. So that, in other words, the problem is to find a space, a mathematical space that's rich enough to model all possible biological organisms, because you want to be able to talk about biological creativity. If you look at the current mathematical models of evolution, which are splendid, it's called population genetics, but creativity is sort of eliminated by definition from population genetics, because population genetics has you deal with a fixed set of genes, and all you talk about is how the frequency of the genes in a population changes due to selective pressures. But no new genes can come in. So what I'm interested in is where new genes come from. And with the model I have, you can talk about this. So in other words, this is a concrete example, it seems to me. Certainly the work of Gödel, I think, is an example of a mathematical result that is philosophically fertile. And And you know, I would love to see a mathematical theorem about, I don't know, how the mind works or what consciousness is. At the present time, we have no idea how to do this, right? But
You're optimistic.
I'm optimistic. I think if we understand something well, there will be some mathematical content there. And let me give us a reference on this. Von Neumann, for example. He could take almost any field and go in and do some mathematics. You know, game theory, quantum mechanics, you name it. Theory of self-reducing automata. And it's so I'm not saying that all of you should stop working in medicine or psychoanalysis and become pure mathematicians. Not at all. But I'm saying that pure math is and Plato, I think, had some sympathy for pure math, is a way of reasoning about things which is helpful. It's helpful to try to do it. Now, very often, to be able to bring pure mathematics to bear on a problem, as physicists very well know, you have to make a ridiculously simplified toy model. But you try to capture the essence of the situation. And so I'm not saying this is a universal solution to anybody, but I'm saying I think it's helpful for pure math to try, you know, to not say.
Economics.
I'm sorry.
Okay, can we go to
economics?
Can I just ask you one question?
Yes, sir.
When you say pure math, are you talking about, like, this from a philosophical point of view, synthetic a priori knowledge? I mean, are you talking about the world as it is, or are we talking about those proofs which can be made within the mind without empirical verifications?
Yes, without empirical verification, exactly.
Yeah, I want to follow up on my earlier question, whether in principle there's anything we can't know. And it's kind of a quasi-Kantian issue. You had mentioned subjectivity. Is there, because we're human beings, any way that we cannot get to, the, quote, the real world? Is there anything about that is just intractable about who we are, our senses, even with science 50 years, 100 years, 1,000 years from now being different? Is there anything in principle unquestionable in that way? Unanswerable, I mean.
Well, I think I'd already expressed what I had to say about all that, but maybe Tim wants to say something.
I feel like I'm going to say the same things, which is there may be, but we don't know. You know, there may be limits, but we don't know what they are. I mean, physics. For example, we have a lot of trouble with physics, right? Sort of quantum mechanics works pretty well, as everyone says. General relativity works pretty well. It's hard to put them together, and so on. I don't see any reason in principle why some nice physical theory you can write down in a page of equations wouldn't work perfectly, and we would all become convinced we got it, right? I also see no reason to be sure that's ever going to happen, right? It may be that the world at base is complex in a way that our minds are simply incapable of comprehending. I don't see any a priori grounds one way or the other. That's what I've been saying all along. So keep going as far. We've gone awfully far. We've gone much further. I mean, I agree in terms of progress. I mean, look at what we've done. Now, can I just make a comment back to Olga? I think we've made a lot of progress on transistors exactly because we're dealing there with a subject matter that mathematics is well suited to represent. Although even there, we invent mathematical tools, and sometimes we have the wrong ones. I mean, I think it's the comment that if all you have is a hammer, everything looks like a nail is really deep. And mathematics itself, you have to invent mathematical tools, and we might be trying to grapple with things with the wrong ones. And there may be some subject matters where electrons are simple, right, and people are hard, right? No reason to think that there'll be a very good mathematical theory of human behavior that'll do nearly as well as we can do with electrons.
Good.
Right?
Okay, question back here.
Game theory is something.
Go ahead.
If we were rational.
Would you say who you are?
Go ahead.
So I'm just wondering the consequences
for...
sorry, my name's Josh Armstrong, a grad student in philosophy. So wondering what the consequences of accepting some of the limitations are for the goals of a scientific theory. In particular, there's a kind of common picture of what physics is, that it's the goals of physics are to describe physical reality in the most fundamental terms. And the question is whether the acceptance of these limitations should cause us to revise this notion of what the goal of physics is, or just makes us realize that it's a goal that we're aiming for, but we're never going to get there. So, yeah, I mean, what does limitation suggest about the goals or the nature of the scientific theory generally, and in particular physics?
Everybody's looking at me, but I just repeat the same thing.
You want to hear something about physics? Physics has, while your back was turned, physics has turned into metaphysics because of lack of ideas and experimental evidence. Have you heard all the stuff about the multiverse? The latest stuff is, I don't care how this particular universe works. It's just our postal address in the multiverse of all possible universes, right? I mean, I've heard real physicists and cosmologists say this, or string theorists say this. So metaphysics is unpopular in the philosophy community, I have a feeling, right? Since analytic philosophy.
It's actually kind of...
but it's alive in the... Or maybe it's back.
It's back.
But anyway, it's very much alive in the physics community, in the fundamental physics community. Surprise, surprise. I didn't know it's back in the philosophy. Good.
Metaphysics, look, metaphysics is a field... It was a name that was put on a volume by Aristotle, who never even used the term, right? For him... he used three different terms, but one is the theory of being qua being, right? One is theory of being as such. That's what exists. It's very simple. You want to know what exists. That's metaphysics. Science, to that extent, is doing metaphysics. It's trying to figure out what there is in the world.
Ontology.
Ontology. I mean, ontology and metaphysics mean the same thing. The logical positivists gave metaphysics a bad name because they were writing Heidegger and so on. Good for them. They were right. There's bad philosophy out there.
Yes, great. But what if I say I don't care what exists in this particular universe? Because it's just our bad luck to be stuck in this particular one. I'm interested in the multiverse of all possible universes, a much more beautiful and intellectually rich space, which is what some people are saying
yes,
now.
I think that's a comprehensible hypothesis. Whether that we could ever conceivably have good reason to believe it, I think your suspicion, and maybe I completely share it, is that even if that's true, we'd never be rational to believe it. This is like Hume on miracles, right? Miracles could occur, but I can show you it's never rational to believe they occurred, right? Because there's always a better explanation. I might be convinced that, but who knows? The universe could be big.
Right, but we're not physicists with tenure. Look how many physicists with tenure have published book on this subject. Brian Greene just published a book.
I agree.
In England, what's his name? John Barrow just published a book on this subject. So
yeah, it's a hot topic.
It's a hot topic.
Did your question get answered?
Yeah, I mean, Tim, do you have anything to say about the sort of goals of the scientific?
But when I said it, I really would just repeat the same thing. Maybe some limitation will keep us from ever knowing completing physics, but I don't see any proof there's any such limitation.
And so you shouldn't think it's a tension between the
right. I don't see we're in a position to throw up our hands now and say I know for sure we're never going to make it. I don't know for sure we will, but I don't know we won't. So I don't see that it changes. And the enterprise ought to be go as far as you can.
But in practice, people are throwing up their hands.
Yes, and
string
I think
theorists are doing it. They're talking about multiverses of all kinds.
It's amazing how relevant Hume still is.
Hume was beautiful.
Close to your mouth, please.
Yes, this for posterity, but quicker this time.
Could you say all the things you said before again?
I can if you want. No, really.
Too far here.
I won't. Okay. So, about the 300 years for robotic rights and 50,000. Recent research was relatively recently published, and a mathematical algorithm was embedded in a dual processor robot, and the second was its only task was to observe the first. And it started coming out with meta comments about itself that were remarkably like a little homunculus. So I just want to say things are moving along in that area. That's one thing.
So there is no limitation.
Right, no limitation. The other thing, and the other thing about, but it's a very good point. I was going to bring up string theory in that it does point out this gap between a mathematical story, which string theory is, and its relation to provability. That it can be a very self-consistent, thanks to Ed Witten, elegant theory, but nonetheless, we have no idea because we can't investigate, again, that level of scale if it bears any connection to the physical reality it purports to be describing. So that's just an interesting proposition within the discussion about metaphysics and limitations.
Thank you. There's a question after.
Well, this young man was the next.
Oh, okay.
Well, can I react to that first, though? the gentleman who just spoke raised an interesting issue, which is that what one means by a mathematical theory has changed. Before, it would have been a system of equations, right, that you would have solved. And nowadays, very often, it's a computer simulation, a computer model, like the robot model you mentioned.
This is a physical robot.
Oh, this is an actual physical. Okay, so you build your theory, you embody it in a.
At Cornell.
I see. Mm-hmm.
I'll post it. If anyone's interested, I'll post it to the discussion.
Mm-hmm. We would.
Stuart Barron, aspiring polymath. Thank you all for participating in this panel. I would love to address every comment that's been made, but of course I won't monopolize so much of your time. We must know, we will know. Seems to me more, rather than a prediction, a statement for the ages, if I may. And the question was posed of whether or not math has proven that there is any limitation on the scope of knowledge. And it seems to me that if it has, in the same breath, it has proven the opposite as well. And lastly, this panel, I suppose, is here to address whether humans are capable of understanding all that exists, if that's a fair statement. And it seems to me that the human mind is a work in progress. The human mind is today, the human mind is a permutation of the mammalian mind and all the minds that came before it, and the future human mind is beyond the scope of our imagination. And so it seems to me that this question will remain open as of today. And lastly, the limitations of the nature of our existence. We exist freely in 3 dimensions and linearly in a 4th, and I'm not aware of the limitations of our existence in the other dimensions that may or may not exist. But it seems to me that this limitation in the 4th dimension of time is quite relevant. So I'd love to hear it addressed if I could just pose that question at large. And I suppose I'll leave it at that. Thank you.
Well, I would like to say that we've been discussing limitations, and that the questions that you pose promise a somewhat unlimited discussion, and that maybe we should limit ourselves and go home and think about them. But I'm willing to. But if somebody wants to disagree with it, please go ahead and we can continue.
Well, I don't know. One more remark that maybe everybody here knows about. Was it Wittgenstein who said if lions could speak, what would we have to talk to them about? One problem is, let's say there are intelligent jellyfish on, somewhere deep in the surface of Jupiter, and they have a wonderfully rich literature. And how much could we understand of that literature? How much would we have in common? How much could we understand? I don't know that this is a fundamental limitation in our abilities that we should be worried about, but it's very much connected with what Chomsky said and you talked about. And
I have a feeling that we should probably quit, but I would like to still use overstep my privilege. Or do you want another question? One more question.
This might take us back a bit, but to help understand what you mean when you ask what kinds of things might we never be able to understand, could we have a few examples of things we do understand?
So that's a very good question, I think.
Proof, yes.
May I add one comment on that?
Well,
it's a one-sentence comment.
Okay.
And it is just
go ahead.
on the fundamental problem that exists in epistemology of the recursive problem of validating premises. This is at the core of the problem with understanding anything.
But I guess I think we do understand a lot. I mean, although I can understand how you might think there's a problem. Let me just give you a very quick example. Okay, so think of all the period of human history where when a lunar eclipse occurred, people got extremely upset. Right? They thought the whole frame of nature was somehow out of whack and horrible things were going to happen, and they were scared. And certainly by the time of the Greeks, I don't know about the history in China and so on, people understood what an eclipse was, right? Okay, it's just that the moon doesn't have its own light. It's reflecting the light from the sun, and the Earth is interposing itself. And in fact, what you're seeing is the shadow of the Earth, and they could see, oh, the Earth is a sphere because, look, its shadow is round. That's a tremendous, deep insight. Now, you can say, but did they really know what light was? Did they really know? I mean, each of the pieces of that explanation, you can push further. And I agree, we haven't gotten to the absolute bottom of anything. But for that particular question, right, what's an eclipse? They got it, right? And there's lots of examples like that. There's lots of things we do understand. And this has come to the progress of science. I mean, I don't think we should denigrate how much we understand, even as we appreciate how much we don't.
Right, but ancient Sumer could predict eclipses. They didn't understand Newton's laws, but they could predict them very accurately. This was 6,000 years ago, I think, or 5.
No, they could predict them statistically, but they didn't understand.
Did they know what they were? Right.
Well, I think his point, Professor Maudlin's point, is well taken. That there are all these levels of understanding. We understand it in a certain sense, but of course, if you push it further, then you can always say, well, we don't understand this fundamental point. I just want to conclude. I want to make one little comment, which I feel I have to, namely. There was something said about string theory in a kind of a derogatory thing. I want to not say anything about string theory's relevance to the world of the physics, but string theory has enabled such fantastic progress in mathematics that it's absolutely remarkable. So it's one of the great intellectual steps forward, whether or not it has anything to do with the real world, people more qualified than I can say, but it is a really remarkable thing. I don't. Maybe I will end it here unless there's a tremendous desire to respond to this statement. Do you?
Thank you.